Hello, in this screencast, we're just going to briefly go through the process of evaluating a recording to see how the artifact reduction is working and dealing with a technical issue in the recording, how to resolve that. This is Michael Guest, VP of Research and Clinical Applications for Persist. And this is a recording that has a technical artifact that's causing an issue with artifact reduction. When I click it on, you can see this departure here. Normally, that's not a problem. It's not going to affect detection or trending. But it can affect other things if you're subsequently performing other analysis on the EEG outside of Persist and you're archiving that artifact reduced data. So how do we deal with that? First is to identify what the issue is. And to do that, I'm going to put the EEG in a recorded or AMP reference montage. This is all the signals coming into Persist. And I'm going to turn off the filters. So this notch filter is off, the high frequency filter is off. And now I'm going to turn off the low frequency filter. And once I go to off, I have channels disappearing. So let's see where they went. We're at 10 microvolts. Let's go ahead and put it to a millivolt. And we've got a considerable amount of DC offset that's going beyond the limits of the AR artifact reduction calculation. And it's identifying that as bad and it's affecting the reconstruction. So let's go ahead and fix that issue. I'm going to go ahead and put this back to 10 microvolts. I'm going to see what filter works. And actually, we already saw that when it went to the 3-second or about 0.05 hertz low frequency filter, high pass. Everything comes back on. That resolves the offset issue. So let's go ahead then and create a copy of this recording, a clip of this recording with that 3 hertz filter applied, but no other changes, no other filters applied. We're only going to do that. So to create that file, we'll go to Tools and Archive. And when I click the Advanced button, I have a Use Montage versus Headbox data. This is normally deselected. I'm going to have it turned on. This warns me that montage data may not be able to be remontaged, but that's not the case with an AMP reference montage. If I had a bipolar montage displayed, it would archive in a bipolar. We don't want that. We want AMP reference data. What we want to do is apply a filter, so that's all we've done in the GUI. So the option to use montage versus headbox data says use the settings in the user interface, which is all the filters off except for the low frequency filter. I've set that to 3 seconds using the recorded montage. In other words, I want all the channels. Select Archive, and I'm going to put this into a folder just on desktop. I have a output folder, and I can export this as EDF. That's the original file format. Normally when dealing with processing files that may have a lot of offset or other large scale deflections, you can use the Persist format. You can start in the 32-bit because EDF is only 16-bit. Now it will make 2 passes through the data, pick a optimal microvolt per bit scaling and write the data. But again, if you use a 32-bit Persist format, initially you don't have to worry about that. So in this case, it doesn't matter because the original file is an EDF, but we'll select that anyway, just to show the process of doing it. Desktop, output folder, and I'm going to write this as a Persist layout file. Again, since the original is EDF, this doesn't really matter, but if the original data is higher than 16-bit, there's something to be said for preserving the bit depth until you need to go to EDF. All right, let's give it a name. Clip filtered. We'll give it a name, archive it, and it's done. So now I'm going to open that file, and we'll process it, and we'll see if that fixed the artifact reduction issue. So right now it's processing. There are the trends building. And once it gets towards the end of this, because this is not a very long file, we'll go ahead and apply the artifact reduction and see if that issue is resolved. All right, we've gotten to the end of that. It is set to wait for new data, so it's not going to the last few seconds. That setting can be changed as well. Aside from all that, let's go ahead and click the artifact reduction button and page back through the EEG. And we don't have those deflections, except for the very beginning where you know, the amplifiers are beginning to settle into some sort of level related to the patient without as much offset overall. So artifact reduction again, and we have pretty low signal amplitude here. I'm going to drop this to 5 microvolts. And we're going to leave the artifact reduction on, page through, and see if we have any of those large scale deflections. And again, I'm looking at the original signal versus the artifact reduced one. The original signal is in the lighter shades, the artifact reduced one is in black. And we can see that this has resolved the issue. So now I can archive the EEG with the artifact reduction on. Doesn't matter what montage I'm displaying, again, because I'm not going to use that montage versus headbox data, which means the position of this doesn't matter. And this ability to archive or export artifact reduced data is part of PERSYST research. Let's go ahead and bring up the advanced button. I'm not going to use this montage versus headbox data any longer. And what I want to do is apply artifact reduction to this. The 32-bit, once I use EDF as the output file, doesn't really matter because that's 16-bit. Click Archive, we're in the yellow output folder, and now I'm going to call this a different name. Make it EDF, and well, we'll leave the name as it is. Save, or we'll just call it AR. How about that? There we go. And you saw those 2 passes flash by really quick. What it does is it again looks at the scale of the signals and picks an optimal microvolt per bit scaling. All right, I'm going to bring up the File Explorer, or just launch PERSYST again. Go to the output folder and go ahead and go to that ar.edf file, clipped filtered one, ar.edf. Open it up in PERSYST. Artifact reduction is not applied, it's not been processed, and once we get past those initial amp settling bit of the recording, let's change our gain from 5 microvolts because of those D1 through D7 depth channels. We don't have those deflections anymore. So that cleaned it up nicely, and that should work. Let me know if there are any issues doing that, and happy to connect and go from there. Thanks.